Good day, everyone. Programmable logic controllers, or PLC, are used in industrial automation to increase reliability, system stability, and performance, minimizing the need for human operators and the chances of human error. Automation is an automatic process typically controlled by computers and sensors. There is usually very little human intervention. The fundamental role of a PLC is to automate processes by sending program control functions to output devices based on signals received from connected input devices. It was first called as Modular Digital Controller or MODICON. It was Richard E. Morley, who was an American mechanical engineer, that introduced it in the automobile industry. He was considered as one of the fathers of PLC. In automation, we need PLC for hardwired panels were very time consuming to wire, modify, repair, and troubleshoot. So replacement from hardwired is necessary for PLC are solid state and not mechanical. Easy to modify input and output devices. Easily programmed and maintained by plant maintenance personnel and be able to function in an industrial environment. A PLC consists of a central processing unit containing an application, program, and input and output interface modules. It is a specialized computer used to control machines and processes. It uses a programmable memory to store instruction and specific functions that include on-off control, timing, counting, sequencing, arithmetic, and data handling. Here is the overview of a simple PLC. We have a computer for programming, a processor, input switches, and output devices, which are motors, lamps, and etc. In the picture, we can see the conventional control panel and the PLC control panel. Here in the conventional control panel, you will notice that it is quite untidy for so many electrical wirings compared to the PLC control panel, which is clean and less wirings. So basically, PLC is flexible with faster response time, less and simple wiring, solid state or no moving parts, modular design, easy to repair, troubleshoot, lower cost, less expensive, increased reliability, and communication capability, which means that it can be connected and operated via remote through RTU and communications available. So interconnection and monitoring of PLC for different systems in a processing plant is feasible and accessible, which will form into a control system. For control system is a collection of electronic devices and equipment which are in place to ensure the stability, accuracy, and smooth transition of a process or of a manufacturing firm. Here we have the components of a PLC. We have the power supply for the CPU and input and output modules. Different input contacts here and output contacts for the output modules. The power supply supplies DC power to the input and the output modules that are installed in the rack. The CPU is the brain of the PLC. It processes the designed ladder program based from the various input devices, executes the user stored program, and sends the commands to the various output devices. We have different switches for the input devices. Sample of these are the limit switches, timer contacts, photoelectric switch, rotary encoder, proximity switch, and etc. Here, the input module forms the interface by which input field devices are connected to the controller. The output devices are devices which are connected in the output module, for which these are the examples: motors, solenoids, and pilot lamps, and etc. So those devices are wired or interfaced through the output module. Here, the PLC output module, a semiconductor called the triac is installed, for which the triac acts as a switch to switch on and off the motor operation. Personal computer is the most commonly used programming device, for it can communicate to the processor. It has software that allows user to create, edit, store, and troubleshoot program in the PLC. A programming console is a compact handheld programming device is sometimes used to program small PLC. Here is a PLC mixer process control problem. For example, a mixer motor is automatically steer the liquid in the vat when the temperature and pressure reach preset values. But also, an alternate manual push button control of the motor is to be provided. The temperature and pressure sensor switches close their respective contacts when conditions reach their preset values. So here, the process control relay ladder diagram, in which the pressure switch, temperature switch are connected in series, and another one, which is the manual push button, is installed to energize or run the motor starter coil. The PLC input module connections are connected and shown here. This is the input module where the pressure and the temperature manual push button are wired. These devices are wired to the input module and connected to the processor of the CPU PLC. The PLC ladder logic program is similar to the diagram before. It has a pressure switch, a temperature switch, and a manual push button connected to the input module. Then the output module, we have a motor starter coil connected as the output devices. So here we have the comparison. A pressure switch from the ladder. Similar here, we have a pressure switch and a temperature switch connected in series and a parallel connected manual push button. Same here on the relay ladder diagram. Then the motor starter coil here is similar also here in the ladder diagram. So they are basically the same. Motor starter coil is energized when the pressure and the temperature switches are closed or when the manual push button is pressed. So the flow of the current from here going to the motor starter is one. The other one is from the manual push button start going to the magnetic contactor or the auxiliary relay or the triac of the PLC. Now we have the PLC ladder program. Here the contacts, the normally open contacts, and then the output contact symbol. This symbol represents instructions. The number here in color blue, like this one, is the I input 1, input 2, input 3. They are all input devices connected to the input modules, and the O or output 1 or the coil or the triac in the PLC. So this blue colored are the addresses which are very important in ladder programming. Now, when we are going to modify a PLC program, there is no need to modify the wiring for the pressure switch, for the temperature, and the manual push button. Same wiring is used, and all that is required is to change is the PLC program. Before, we have the pressure switch and the temperature switch in series and connected to a manual push button here. But now, since we modify the process, we only parallel the contacts of the pressure switch and the manual push button, and both of them are in series connected to the temperature switch as precondition to start the motor starter coil and energize. So here we only modify the ladder diagram and not the wiring for the input and the output devices and the input and output modules. Now, shown are some of the PLC instruction symbols used in programming the ladder diagram. And also here is the typical PLC instructions and descriptions which are being used in the PLC programming. Sample are the XIC, which are examined on, or sometimes these are called mnemonics, which sometimes called XIC, XIO, OTE, or the abbreviation of the function in the instruction in making those ladder diagram in the PLC. Now, the PLC interface connections of different PLC in each system can be connected through the Ethernet or controller link. These yellow lines shown here are the Ethernet or the control link that connects the PLC through the Pt-HMI and other programming and maintenance software. So PLC, we have a different PLC for each system, and this PLC are also connected to a small PLC via device net. So we have a two communication interface, which are the internet and the device net. Now, there are so many PLC applications, some of which are used in material handling, conveyor system, and so on. We use this in the manufacturing processes in different industries. We have a comparison for PLC versus the personal computers. Sometimes PLC operates in the industrial environment, programmed in the lay ladder logic. It has no keyboard, CD drive, monitor, or disk drive, but it has a communication ports and terminals for input and output devices, which the PC don't have. PC is only capable of executing several programs simultaneously in any order. Some manufacturers have software and interface cards available so that a PC can do the work of a PLC. But as I said, it has no output devices because there is no interface for the output devices and the output modules. Everybody knows Steve Jobs, so one of his saying is that we have to learn continually, or there's always one more thing to learn. Thank you.